Lecture, I was attended online because of the weather, but it's okay. It's recorded. We can go through it again. Yes. So hopefully today we will be able to finish chapter 2. What did we say about our aim in chapter 2? Is to solve first order differential. The first method that we learned was separation. Then we talked about linear, and then we will talk about exponent. What we will do today is that we will solve one more example on exact differential equation. Then we will discuss the non-exact differential equation. Okay, so we can transform it exact. And after we finish, we will go into section 2.5, in which we will talk about solution by substitution. We will discuss homogeneous ODE, and we will discuss also Bernoulli's equation. We will find out what do you mean by exact differential equation. So to say that a certain differential equation is exact, first, how should we write it first? Yeah, but it should be MDX plus MDY equal to B. What's the condition? MY equal to B equal N. So if it satisfies this condition, then it is an exact differential equation. What's the method of the solution here? How do we solve it? We said that we will have F. So the method of solution, we said that we'll have F equal constant, and we will have two equations. Fx is M and Fy is M. Then we will integrate the first one with respect to X, and we'll get a constant in Y. And then we will integrate the second one with respect to Y and get a constant in X. And then we will return only one F as F equal. So the solution that we will get, it will be implicit solution. No need to make it as explicit unless we are asking. Okay, so let's solve this example. Let's think about this example. I will zoom in. Okay, start with it, revise the ideas of exact differential equations. We start with this one. First of all, we need to identify what's our M and what's our N. Go back to the lecture, what's this in order to solve it, because this one is more known. So again, we'll solve this example on exact in case there's some problems that we are facing. We'll talk about non-exact, how to transform it to exact, solve an example, and then we'll move to section 2.5. What's our M?
Equal to y minus y cosine.
Exactly, this is our M. And what's our M?
2x equal 1 minus x cosine x y.
Now for M, Ahmad, what do we need to find? M1. M1. And Sultan, for M, what should we find? Okay, and to be exact, Abu Zaid, they should be what? Equal to each other. So let's find My and NX. Miss, we may use derivative of e power u is u prime e power u, and derivative of cosine u minus u prime sine. So what's e power 2y minus y cosine xy. Okay, and is 2x e2y minus x cosine xy plus 2y. This one we said that we will find my for it, we will find for this one and x, and then we will compare them together. And y, e power 2y, we said that it is. Okay, now this one, it is something times something in 1. So u prime v plus v prime u, right? U prime is 1 multiplied by cosine x1 plus v prime, it becomes minus x sine xy, and all of it multiplied by what? You told me that the water came into your house and
The rain stopped.
Mhm.
The rain stopped around 50 minutes. I think. Okay.
according to the weather forecast, it will stop, the storm will stop today or it will continue.
There's 90% that it continue tomorrow. Till now. To make there's yesterday it was 50%. Today, but tomorrow. Now it's 90%.
Smith, with respect to x, the sun becomes 2e 2y, right? And this one, it becomes 0, right? This one that is here, Miss, again, u prime v, it becomes cosine 1 plus v prime u, we will get x, y multiplied by negative. Why do we have negative sign it become? Let's compare these ones together. What do we have here? 2e, 2y, we have it also here. Here we have minus cosine xy, and here minus cosine xy. And here we have minus xy, and here what do we have? Minus. So are they equal?
Yes.
Okay, so is it exact? What can we say? Y equal x. So our ODE is. We cannot start with anything. We just did a quick revision of the exact. What does it mean? And this is our first example that I start. Everything before this has to be. So we proved the first step that it's exact, but we haven't solved it yet. Once you finish writing from the board, please go to our lecture notes and check how we can solve it and start solving it. What's the next step now? This is our first step, right? The next step, our solution at equal constant is the general solution of our ODE. Okay. This F, what does it satisfy, miss? It satisfies two equations we set, right? F equal M and Fy equal M. Right, miss? So let's go. Fx is equal to what? M, which is e2y minus y cosine x. And Fy, miss, it is 2x e2y minus x cosine xy plus 2y. Till the step, are we okay with it, miss? Now, to get rid of this x, miss, we should integrate with respect.
Sorry.
And to get rid of this y, we should integrate with respect. Remember, when we integrate with respect to x, the constant that we will get is with respect to y. So we'll write cy or gy or whatever. And when we integrate with respect to y, we'll get a constant with respect to x. So we'll write it as g of x or h of x or whatever. Noor, do we have questions? Anyways, you're muted, we are unable to hear you.
No, miss, I don't have any question.
Okay. We'll start with the first one. Now, the third step, we need to integrate. So f is equal, and f is equal to integral e2y minus y cosine xy. We are integrating it with respect to x. And in the second one, we'll integrate it with respect. Again, here we will get plus constant in y, and here we will get plus constant in x. Right, miss? E2y with respect to x, E2y is a constant with respect to x. Okay. Minus y cosine xy. Cosine a t dt is equal to what? 1 over a sine a t plus a constant, right? Okay. Here we are integrating with respect to x. What's our t here? What's our a? 1. So what will we get, miss? Minus y over y sine. Right, miss? And of course, y over y, we can cancel them together, provided that y is not 0. So done with the first one. Now let's find the antiderivative of the second one. 2x e2y with respect to y. Again, e a t dt is 1 over a e a t plus constant. Do we agree? Right, miss? These are from the table of integration. So 2x e2y, 2 is the constant, we will get 2x over 2 e 2y. Again, this one will deal with it the same as this one, but here with respect to x. So what's our, with respect to y, what's our a? A is x sine xy. 2y with respect to y, it becomes y. So these one will be cancelled together, 2 and 2 are cancelled together, x and x are cancelled together. We integrated, now we need to compare. What are the common things? What are the things that they are not? Let's look now at this one. Is it found here?
Yes.
Okay, so right. Let's look at this one. Is it found here? So we will write it. Now, what are the things that they are not here? Y square only, but as if it's here, why? Because you have C of Y. So C of Y as if it's equal to Y. Here, do we have anything in X only? So G of X will consider it as U. So here we are doing comparison. Okay, miss? Any question? Write your new function now. What's your name?
Joy.
Is your first name?
No. Absent for 1 week. I have attended the first week.
No.
The second week.
How are the roles now? Bigger than before?
That's what's something.
So you're coming from the city or from around?
From the city.
And how's everything till now? The roads are flooded or no?
Nothing slow.
Maybe because it stops a little bit. But here we had some once.
And if it since the group that it's cancelled.
Who said trust? I.
Something it's
No, miss. If I want, first of all, even with the weather, we don't cancel the class because there is another option, which is the online. So it's impossible to cancel the class at all, except if we got from the ministry that it's an official holiday. Otherwise, we will be either if there are some reasons, we will give the class online. So we don't cancel. And there will be no announcement except if it's from me, I will be absent, let's say, or for whatever the reason is I want to give online, or from the university. Did you receive anything from the university? Not yet, right? Okay. So what will be at now? F is equal constant, so F is x e to y minus 5xy plus y squared equal constant, and this will be what we call an implicit or explicit solution. This is our implicit solution. Any questions about exact? Now, even if we still have some more concerns about exact, when we talk about non-exact and transform it to exact, we will also solve again on that. Look, I have checked what we took last week. It was recorded. Okay, please do that as soon as possible because our examination will be actually 2 weeks.
The due date is today.
For submission of the file. If you need more time, I can give it as I can extend it a little bit for Wednesday.
The submission is with the code, not
Yeah, but one of the groups will submit. If you want all of you to submit the same file, just write your names. Okay. Now, our next aim, so we covered the first part, the exact, let's go back to objective. So we know how to identify, we know how to solve. Now, the next step is we have a non-exact differential equation, but we are able to assert an integrating factor to do what? To transform it into exact. Again, what do we mean by integrating factor, miss? We are multiplying the whole equation by a certain function in order to make it easier to solve. Okay? But does that mean that every differential equation I can transform it to exact? No. There should be a certain condition in order to transform it into exact. So we need to discuss our third objective. If an ODE is not exact, what do we mean by an ODE is not exact? It means that my is not equal to an x. we will find my minus nx over m. My you have it, nx you have it, subtract them, divide it by n. If it's a function of x only, then this will be our integrating. Then this will be our integrating factor. What do we mean by integrating factor? Again, multiply it by the whole equation. Okay, miss? Now, if this one is not a function in x, but if we did nx minus my over m and it's a function of y only, then our integrating factor, it will be this one. Again, why do we need to multiply by integrating factor? Because we need to make it a little bit more simple. What do we mean by simpler when we are talking about exact? It means that we are transforming the non-exact differential equation to what, miss? To exact one. Okay, and this part it will be a little bit difficult for you to understand because it depends on the exactness. Hopefully, when we start the section with section 2.5, it will be okay. Okay, miss? So please write these notes. We will give an example to illustrate it, and then we will move again. The first step, find your and check if it's exact. If it's exact, go ahead and solve it. If it's not exact, check if we are able to transform it to exact by finding this one. If it's a function in x only, find your integrating factor. And if the second one is a function in y only, find your integrating factor. Okay, we'll illustrate this with this example. Do you finish writing from the board? Okay. This example. First step must just identify your and check if it's exact. Okay, miss? What's our m? M is before dx, so m is xy. And what's our m? Okay, 2x squared plus 3y squared minus 20. So check if it's exact or not. What's my? My is what means? And what's m? Are they equal? You told me that m is xy and n is 2x squared, 3y or 3y squared,
Minus 12.
3y squared minus 20. So we need to find for this one my, which is, and x, which is, are they equal? So we will call this one E, O. What can we use? Apply the O is not x. The first step, are we okay with that? Are we okay with that? So this one is not exact. We want to check whether we are able to transform it to exact or not. So what do we need to find as? Can we find it? My minus nx over n, right? If this doesn't work, what do we need to find? Nx minus my over m. This should be in y and this should be in x. Okay. My, you told me it's equal to? My is equal to x, right? We found it.
Yes.
And x is 4x over m, 2x squared plus 3y squared minus 2, which is negative 3x over 2x squared plus 3y squared minus 2. Is it a function in x only?
No.
Do I use it? Do we use it? Okay. What should I check? The second one. Now, if it's a function in x only, do I have to check the second one? It's a function in x only, miss. Do we check the second one?
No.
Okay. So the second one, miss, nx is 4x minus my is x over m, which is x. What will we get, miss? 3x over xy. Provided that x is not 0, we will get 3 over y. Are you okay with 3 over y? Y function and y only. So we will use this one. Okay, miss? So this one, we will use it in our integrating factor, and this one we will not use it.
After we do presentation today?
No, miss, of course. I did not say that we will do it today. We said Thursday, right? I will give you deadline for today and Thursday. Okay. Go back to this one. What's our integrating factor now? We use the first or second? So what will be our integrating factor? This mu, right? So the next step is we need to find the mu of y. Mu of y, we said that it's e power. This one it was nx minus my over m and ey, right? Which is e. What was the value for it that we got? 3 over y, right, miss? The integral is 3 over y. Remember this, an integrating factor was constant. We don't constant, right? Because we want to find an integrating factor, which should be easiest one, which is the constant is 0. Okay, miss? So e power 3 over y is e power 3 ln y. Remember in linear equation, what did we do for this one? Ln y cube, and this one it will be y. So this one it will be our integration.
Doctor, why did you not write C?
On our integrating factor. Now let's go back again to our ODE. It was xy dx plus 2x squared plus 3y squared minus 20 or 2? Minus 20. Minus 20 dy equal to 0. What do we need to do? We found an integrating factor. So we will multiply by mu of y. What did we get it at? Y. So we will multiply the whole equation by y cube. That is not 0. What will happen when we multiply the whole equation by y cube? What will be the new equation? Xy, it becomes xy, it becomes what? Xy4 plus this one, 2x squared y cube plus 3y squared y cube will get y5, and this one minus 20 y cube dy equal to 0. This new equation, after we multiply it, we will call it as now. And instead of solving O, what would we solve? Mister, if we have an equation and we multiply it by something that is not 0, that is the solution affected?
Yes.
No. Okay, so I'm telling you x equals 5 and your colleague is telling you 2x equals 10. The solution is affected, Muhammad?
Yes.
Equal 5 and 2x equal 10. Do they have the same solution or?
Yes. Yes.
Also for differential equation, when you multiply by a function that is not 0, the solution is not. So here, what can we say? O and M have, what do they have, Miss? The same solution. If you still remember, we weren't able to solve O because it's not exact. So what will we solve now instead? And while finding the solution for M, it means that it will be the solution of O. Yes, Hamza.
There's supposed to be dx there.
Yeah, the x of course. So this one we will copy it the same. So here, what will we solve? We solve M instead of O because O we weren't able to solve it. Now, what I need from each of you to do, each two together to solve M. Forget about O now and solve M.
Do you repeat the same steps? Get everyone and
You have now you want to check the exactness, it should be exact. If it's not exact, it means that you had a certain mistake. Now, again, let's write again our new ODE map. It is xy4 dx plus 2x squared y cube plus 3y5 minus 20y cube dy equals to 0. This one is our m, and this one is our brightness. This is the new m and the new m. Right, Mu'ayyad? Okay. M is what? X by 4. And y. And it's 2x squared y cube plus 3y5 minus 20y cube. We need to find an x. So my is equal to what, miss? What's my, miss?
4x, y.
Okay. Do all guys agree with Abu Said that this is my? Abdullah, what's an x?
-2, -20.
An x. These ones are considered as what with respect to x, miss. With respect to x, this one is 0, right? So this one, it becomes 4x y cube. Are they equal?
Yes.
So what can we say about our body? M is exact. If M is exact, how do we solve it, miss? Can we solve it now? Okay. Please, each two together solve it. We need to say f equal constant, fx equal to m, fy equal to n, and integrate. What will be the solution, miss? F equal constant, fx equal m, and fy equal to m, right? Start with it. We are doing the steps since we have to practice in class. So you got the solution, Sultan? So again, fx, what was m, miss? Fy4 and fy. What was fy?
2x squared y plus 3y.
So here we will integrate with respect to which variable? And the second one with respect to y. Perfect. Okay, and then again, remind me, when we integrate with respect to x, the constant will be in terms
One.
what? Okay, after that one. So the first one, f is integral xy4 dx, and the second one, f is integral of 2x squared y cube plus 3y5 minus 20y cube, and here dy. Y4 with respect to x, no?
X squared. 1.
Plus constant in what?
One.
Y. Are you okay with it, miss? The second one,
The first time. Screen.
Oh. so 2x squared stays the same, y2 it becomes y4 over 4, right? Plus 3y5 means it becomes minus 20y cubed, it becomes y4 over 4 plus the constant L and x. Rewrite it in a better form, like simplify. So 2 and 4 simplify them, 3 and 6, 20 over 4. What will be x now? X squared over 2 y4. Okay, the other ones, are they common? Okay, so let's write down plus y6 over 2, right, miss? Minus 5y4 plus is equal to constant. So this one is now solution for the ordinary differential equation O and solution for what now? For MS. Any questions, miss? Do we have questions? Who solved it correctly other than Sultan? Abu Said, Abdurrahman, who solved it correctly, Ali? Here's mine. Were we able to solve it?
Yes.
I thought we're not solving, right? Why? Miss?
I don't understand.
Why?
I have to rewatch it.
Okay, so go back to the material now. The section 2.5, it doesn't depend now on section 2.4. But if you focus from the beginning, we'll be able to understand. Okay, miss. I would like to use some exercises to solve. So let's say you can solve this one. This one. Share it with you on Teams, and then we'll start with a new section. Should do the schema for Ramadan. So our class will continue starting at 9, but we will end it at 10. And I sent you the schema for all classes. Okay, so let's recap. Our main objectives, they were to identify exact differential equation. So how do we identify exact differential equation? Y equal and how do we solve an exact differential equation, mass? F equal constant, Fx equal m, Fy equal, and we integrate, right? Then we talked about multiplying by integrating factor to change the non-exact to exact. We're done with section 2.4. We still have only one more section in chapter 2. And we will be done with first order differential equations. So this is our last section in chapter 2. It's about also first order differential equation, and we will solve a differential equation using substitution. In order to understand this lecture, we need knowledge about the integration formulas, separation of variables, and linear semi-ordered differential equation. Our main objectives are to solve homogeneous ODE and solve Bernoulli's equation. But before just solving, we need to identify if it's homogeneous or not. For Bernoulli, we need also to identify is it Bernoulli or not. Okay, miss? So we'll start with what's meant by homogeneous function, then homogeneous equation, what do we mean by it and how we solve it, and then Bernoulli's equation, the general form of it and how we solve it. But even like if we are solving homogeneous or Bernoulli's, we will solve it using substitution. We still remember substitution, right? In integration, instead of the variable that you have, you change the variable to something else. Let's say I have e power y squared. I will put like u equal y squared. So here almost the same. Okay, miss? The homogeneous that we are talking about here for first order differential equation, it's not the same as homogeneous that we know equal to 0. Okay, so first we will define what's meant by homogeneous function. We have function in more than one variable, x and y. To say that it's homogeneous, if you put fdx, dy, we will be able to get theta or something and just multiply it by xy. If you look at this example, at xy equal x squared plus by squared. So what we need to do here is to find f dx dy. What do we mean by dx dy? It means that instead of x, what do we need to put?
Here.
And instead of y,
0.
miss, when we have f of x equals something and you put f of 5 instead of x, you are putting what? 5. So if I say f of t, it means that instead of x, we are putting. If I'm saying f of t squared instead of x, we are putting t squared. So here, f dx, it means that instead of x, we are putting tx. And ty, it means that instead of y, we are putting ty. So it is x squared plus 3y squared. You told me instead of x, what should I put? Tx. And instead of y, ty. Right? Okay. What will be the answer of this one now? Let's f of dx dy is equal to expand it means t squared x squared plus 3 t squared y squared, right? Right, miss? What was f of x squared? Plus x squared plus 3y squared, right, miss? This one that is here, can we write it as t squared into x squared plus 3y squared? Are we able to take t squared common? Okay, so what did we get exactly? What is what, miss? It's f of x one, right, miss? So we got it. Does it satisfy this one?
Yes.
Okay, and what's and that we got it? So the homogeneous here is of which degree? Degree. If we got t cubed, it will be degree 3, and so on. Is it necessary that every function is homogeneous? Let's give an example. So let's say, okay, write xy plus 3. Check if xy plus 3 is homogeneous or not. The next question is, we need to find this. F
dx 0.
instead of x, instead of y, dx dy plus 3, right? So what did we get here? T squared xy plus 3. are we able to take t squared? Are we able to write this one as t power something multiplied by xy plus 3? So it's not t. So what can we say about f?
That's how.
No? Homogeneous. Okay, miss? Are we able to differentiate between homogeneous and non-homogeneous mass?
And bit by this.
To be homogeneous, you should write it in this way. T power something times half. Are you able to write it in this way, Roel? So it's not homogeneous. If we go back to this question, we were able to write it T power something times half. So it's homogeneous. We're done with the homogeneous function, what we mean by it. Now our aim to deal with homogeneous equation, because our main objective in this chapter is to solve first order differential equation. So we solve it with integration variables. We check the method of linear equation. We talked also about exactness, non-exactness, and now we will discuss the homogeneous differential equation. So again, a first order differential equation is given in this way. Okay, miss? To be homogeneous, and should be homogeneous function. But also it's not necessary just to be homogeneous function. With what? Same degree. What do you mean by same degree? Like if we have t squared here, what should we have? T squared. So if M has t squared, then M also it has t squared. If M is homogeneous, it has t cubed, and M is homogeneous, has t4. Can we say that the differential equation is homogeneous? Why? They should be what? Same degree. Okay, Abdullah. Let's look at this one, miss. This one, if you go back to this one is homogeneous of which degree? 2. And also this one, if you look at it, this one is homogeneous of which degree? 2. So the whole ODE, is it homogeneous? Is it homogeneous or not? What I need from you to do is check for me if this one is homogeneous. So let's say x dx is it homogeneous or not?
Yes.
Okay, the first one is homogeneous of which degree?
2.
X is homogeneous of degree 2.
No, the first degree.
This one is of which degree, miss? You told me? 2. This one,
No, I need the first equation.
the first, yes. The second one, this one is of which degree?
Sorry.
So is it homogeneous? So again, to be homogeneous, we need M and both of them to be homogeneous, but also of which degree? Same degree.
Sorry.
Okay? Again, for this section, whether homogeneous or Bernoulli, we will solve it using substitution. So we will introduce a new variable that we will deal with. Okay? Why, by the way, why do we usually use substitution? To make the in integration, to make it easier. So here basically, what do we need for this homogeneous equation? To make it easier in order to solve it. Usually this homogeneous equation, we do this substitution to make it what's the easiest ODE to solve? Separable. Is that the easier? So we transform it. How do we start? First of all, we need to make sure that it is homogeneous. Then we are saying that we need to use substitution. So the substitution that we will use is y equal u. So we will not have y anymore. Instead of y, we will put instead of it what? Ux. Can we have an ordinary differential equation that contains ux, du, dx, and dy? Does it make sense? So what do we need to get rid also of? dy. When you have an integral in x and you are saying let u equal something in x, do you keep dx or you get rid of it? Write it in terms of du. Perfect. So here, how do we get rid of dy? We would write it as u dx plus f du. This is the product rule. U prime x plus x prime u. U prime x plus x prime. Okay? Then what do we need to do? Substitute in the differential equation. The new differential equation, it should be what, Miss? Separable. If it's not separable, it means that we did a mistake while substituting. Okay? The method of solution, are you okay with it? So first, check if it's homogeneous, same degree. Then use the substitution y equal ux, and then substitute instead of dy u dx plus x du, and we will get a separable differential equation. Please write them in order to use them for the first example. So what we will do now is that I will solve the first example in detail, then I will give you time to solve the second example, and I will be passing by you for your PA, by each of you for feedback.
What's assumed that we can use?
I'm waiting for the others to finish writing. Are we done writing from the board? Okay, let's look at this exercise. We will solve it together. What's happening? What's our amness?
X and then y
And what's our an?
y.
Minus that. Everything before dy is. So, is it a homogeneous differential equation? Is it homogeneousness?
Yes.
Okay, so let's rewrite it again. So m is x squared plus y squared, and n is minus x. What do we need to find, Miss? M tx ty, and here what do we need to find? M tx ty. So again, instead of x, what should we substitute?
Yeah.
And instead of y,
Zero.
ty. Let's substitute. What will we get, Miss? Tx squared plus ty squared, which t squared of x squared plus t squared y squared. Right, Miss? Can we take t squared in common? Square plus y squared is exactly what? So we got n of which degree?
Zero.
In order for it to be homogeneous, what do we need to check, Miss, here? What should we check also? The n, right? So this one, can we write it as t squared to negative xy?
Yes.
So what did we get it as?
You need to also.
T squared and which degree also? Same degree. What can we deduce? The whole differential equation is what? Homogeneous. Is it okay?
Yes.
So our ODE is homogeneous. Now, in order to solve it, we will do these steps, okay? It's homogeneous. Can we move now to the next step and do substitution? What's our substitution for homogeneousness? Y equal
Yes.
ux. So this is the first step. Now, the second step is we will use our substitution y equal ux. And again, dy is u dx plus x du. Substitute in the given ODE. Okay, miss? So what was the ODE? Let's rewrite it again. So it was x squared plus y squared dx minus xy dy equal to 0. So these y's that we have here, what do we need to put instead of them?
Yes.
Exactly. So x squared, right? Plus y squared. We are putting ux, right, miss? Then minus x. Instead of y, what should we put, miss? Ux. And instead of dy, what should we put, miss? U dx plus x d. The first step, are we okay with it? Abdullah Muayyad, are we okay with it? The first step? Hamdi, we're okay with it? Smile. Luay and Ali and Abdul Rahman, are we okay with it?
Just to replace.
Yes, till now it's just replacement. Now, after we replace, we need to simplify, rewrite it in a better form, okay? So we got this one, miss. Now let's rewrite it in a better form. So this one, x squared plus square u squared dx, right, miss? This one is minus x squared u squared dx, the first entry, right? Expanding, miss. X squared u squared dx, right? The second one minus x cubed u du equal to 0. Please check if this is correct or not. Now the first one, can we expand it as well? So this one, can we write it as x squared dx plus x squared u squared dx? We are just expanding. I am expanding only. Okay?
No, just for
You got it? Okay. We reached this one. Now, before we move to the next step, check if there are some terms that we can cancel by now. So after substituting, expand. After expanding, check if there are some terms that we can cancel them out.
With x squared, u squared, dx, we can cancel it.
Okay. Are there some terms that we can cancel out?
Yes.
This one and this one. We can cancel them, right? What will be the new one now?
X. Yeah.
X squared dx
Minus.
minus
Q.
x cube u du equal to 0. Okay? Now, I will share. Oh, okay. I will share it anyways. Okay. We know that the new differential equation should be what, Miss? Separable. Let's check. Is it separable? So, x squared dx equal x cube u du. Right, Miss? Everything in x to one side, everything in u to one side. Can we do it?
Yes.
So bring this x cube to the this x cube to this side. What will we get? X squared over x cube dx equal u du. Is it separable? Is it separable or not, ma'am? Were we able to separate x and dx on a side and u and du on another side? Okay. Now, can we write this one as u du equal dx over x? This is the simplest form, right? Can we integrate that? We got this variable, we write it in its simplest form, and then what do? We integrate. Risky. If there's something urgent for this form, we can do it outside the class. Otherwise, let's keep it aside. We got this one now. What do we need to do? Integrate, right? So u du is equal to integral dx over x. U du, what's the integral of that? And this one,
Then
lim absolute x, and we need a constant. Usually constant, we put it with the independent variable x. Now we can write it as u squared equal to lim absolute x plus c or c. Both of them are the same, whether we use c or 2c. But here, miss, we found u. Did we find y? So here, this step, we find u. But what was the initial one? What do we need to find, miss? Y. So how do we find y, miss? What was y? Okay, so what do we need to do for this one? Y equal ux. So u is equal to what? So y is equal ux, but instead of u, we will substitute y over x. What will we get? Y over x squared equal to lim absolute x plus 2c. This one, what do we call it? Implicit or explicit? Here, the explicit solution is easy to find it, but it's okay for now. We can keep it this. So, miss, when we are using substitution, it's the same as integral. You use substitution, you will get the answer in terms of the new variables that you did. But the final answer should be with the original variable that is given. And here, the original variable is y. Do we have any questions? So let's go back briefly. This was the differential equation that is given. First of all, we showed that I would say it's homogeneous of the same degree. Here the degree is 2. Then we use this box, which is we will be using it in any question about homogeneous. Y, instead of Y, we put UX. Instead of dy, we put this one. And then we write them substituted, expand, simplify. What did we get? Separable differential equation. The separable, we put u and du on a side, x and dx on the side. Then what did we do? Integrate. After integrating, we got u, but our main objective is to get what? Y. So instead of u, what did we put? Y over x. Why did we put y over x? Because y is ux. And then we found our solution. Do we have any questions, Miss? Any questions before we proceed? Now, what I need from you to do is, by the way, this is 2c, you can simply just write c instead of it, another constant. Okay, so what I need from you to do is each two together to solve this equation, this differential equation. Done, Abdullah, right?
Yes.
So while I'm taking attendance, Miss, I need from you to solve this equation. So do all the steps, show that it's homogeneous, and then solve. We can solve that, Miss, each two together, or if you want to solve it alone, you can feel free to do. Okay, Miss? After we finish this exercise, Miss, we will give feedback on our first homework. Here, Noor is not here. Abdelaziz, Mahmoud is not here. Shams is not here. Muayyad is here. Luay is here. Sultan here. Abdullah is here. Darshad is here. Ismail is here. Abu Zaid here. Amru is not here. And Shani is not here. Ismail, Ali Ismail is here, and Ahmed al-Tayyib is not here.
Miss, can you mark me as present?
It's homework 2. It will be due on Monday, March 11th. Yes, what's your question?
I think it's my notes. The last one was that the reason why I was when I came to the channel.
Yeah, don't you have the recordings? The attendance, okay.
فالهو كان يسبيتون the first way from what I did.
Miss, you will do it on the weekend. Period of which degrees?
Two.
How do we start? Y equal ux and dy is equal. Did we make it all? Okay, after substituting, what did we get after substituting this? Mhm. Did all of us substitute or not yet? We substituted. Okay, did we simplify? Mhm. Okay, so let's wait a couple of minutes so that you finish. Okay, so what did we get now? We substituted, this is the first step, did all of us did it?
Yeah.
Substitute, okay, then expand. When we expand it, there are things that we can cancel together, right? This one and this one are cancelled. Do we still have any other things that we can cancel? Okay, now the next step, we need to make it separable. So dx and x alone, and du and u alone. So what's dx? Here we have this one dx and this one dx. What are they common with it? So we have x squared plus u x squared dx, right? This step is Sumaya.
So, how it became u squared by x squared minus 7.
Plus ux squared dx, and here minus u squared x squared dx. Okay, we are doing expanding, term by term multiplication. The second one is, where is du? Du is here and here. So what will we get? X cubed minus u x cubed d. Right, miss? Part, are you okay with it? Then miss, dx on a side, du on a side, right? Then x and dx on a side, u and du on a side. What did we get, miss? We will get this one at the end, right? Now our aim is to solve this one.
So,
Now the next step is integration. Which step did you reach? Did you separate them? Okay. Okay. What did we get here, miss? dx over x equal u minus 1 over 1 plus u d. So u minus 1 over 1 plus u du is equal dx over x. This one, do we know it's equal to what?
Yeah.
Ln absolute x plus constant. So then what do we need, miss? We need this integral. This integral is not in the table of integration. I'm not sure in calculus 2 if you solved it by long division, but there is an easier way. When the power, this one we can simplify it as what, miss? U minus 1, what do you have in the denominator? 1 plus u. Write it in terms of the denominator, 1 plus u. What else do I need? I add 1, so I need to subtract 1, right? Can we write it as the denominator minus 2? Can we write it in this way? U minus 1, can we write it in this way, miss? Okay, suppose that I have 2 plus u in the denominator. What will I write it? U minus 1 is 2 plus u minus 3. Okay? Now, what will we get? We will get integral 1 plus u minus 2 over 1 plus u du is equal ln absolute x plus constant, right, miss? These terms are the same. This is our aim, to make it the same. What will we get now? 1 plus u over 1 plus u minus 2 over 1 plus u du is equal ln absolute x plus, right, miss?
yes. That side will be more.
This one is already what? 1. What's the integral of 1? U. And this one was the integral of 7? And the one is then absolute x are being done is our answer completeness. Okay, so what do we need to put instead of u? U is equal y over x. So we substitute instead of u y over x, and then do we have any questions so far? So the last step, we will just substitute and get this one as our final answer. Okay, miss? Have any question? Okay, let's recap. Let's go back to the objective. So we finished this part and the homogeneous equation. Again, to solve homogeneous equation, first of all, make sure that m and n are homogeneous with the same degree. Then use the substitution y equal ux, dy equal u dx plus x du. Substitute, expand, simplify, move u and du to a side, x dx to a side, and then simplify it and integrate. Any question? What we will do now, I will give you feedback on the, will give feedback on the homework. Usually the homework, we don't send the feedback by words. We usually give the feedback in class to make sure that by discussion. So the first exercise, miss, this one, how do we solve it? X and E3X, are they dependent on each other? So this one, either we use tabular integration or integration by what? By parts. So basically this one is integration by parts. Now this one, if you look here, U depends on T and U depends on X. So it's a function of how many variables?
Yeah.
2 variables. So is this one ODE or PDE? What are our variables? U is the dependent and the independent are T and X. Now the equation y w prime plus 2y prime. What's the order of it first? Okay, and is it linear? Where is the non-linear part, miss? Y prime makes it non-linear. Now, y prime plus 2y equals 0. We need a one parameter solution of it. So here we have two options. Either we solve it, or because we have here three options, we can substitute the one that makes the left equal to the right. It will be a solution, right? Which one made the left equal to the right? Okay. Now this one, already we are given the one parameter solution and we are given initial value problem. What do we do here? So y of 0 equal 1, it means that 1 over c equal 1. It means that c is equal to what? Yes, y of 0 equal 1, right? So instead of x, what should we put? 0. 1 over 0 plus c, it means that 1 over c equal 1. So c is equal to what, miss? 1. Which one should we choose? Did we solve it in this way? Now this one, which one is separable? First one, how can we write it? E power x dot e power negative 3y. Now this equation, we need to solve it. How do we solve it? This is a separable differential equation, right? Okay, can you stand the x on a side and the y on a side? Please do it, miss. Okay, so cosecant y dx on a side minus cosine square x dy on the other side, right? Then the cosecant y, you will send it to dy. How can we send it to dy? 1 over cosecant y. What's 1 over cosecant y? It's equal to what? Sine y, perfect. And 1 over cosine square x, it's what? Secant squared. What's the integral of secant square x? Tangent x plus c. And what's the integral of sine y? Negative cosine y. And already you have negative, so cosine y is equal tangent x plus c. This one, miss, is it separable? Are we able to use separation of variables to solve it? Make sure that you are able to access the book. Please, all of you open your Blackboard. Go to reading material. Did you open it? Are we able to access the book? All of you, please check if all of you are able to access the book and the assessments that we will have. These assessments are for practice. Those that they are joining online, please follow the same steps as well.
It's from the rating was here.
Hmm?
Rating will be. Rating.
Yes. Okay. So if you see here on the roster, no, you're not here. Only I have one student. On the roster, yeah, 12 students, and no, one student in section 2. So anyways, when you go here, miss, here you can access the book by pressing on the ebook. And here we have, I put some exercises as practice. It means that this one is not graded. This is for practice. Okay, miss? So we have here a few exercises. They are just for practice. Are we able to access the ebook and the practice? This is our ebook. When they ask you to access your content, I just press continue without account. But if you have an account app, where you are able to access the documents,
Do
do you have account? Okay, so if you don't have account, say continue without account.
There's no option for continuing that.
Okay, so you have to put your account as the edu account. It didn't allow you. Let me check here, where's the problem? And here's create. So please create an account. Because the connection was because it's working. So let's wait until it.
No, the phone doesn't work.
Oh, the phone doesn't work.
It's not. I got the authentication model.
So create an account, Miss, using Singlish.
Also, forget this.
Okay, we have till now Saeed and Hassan is here, Shani is here, and Ahmed. Ahmed is here as well.
Yes.
So anyways, you can ask any of your colleagues how they managed that. Did it work, Sultan?
Make signing automatically.
It's, maybe you have a class before using Singlish and already you did it. You did your sign up. Like Pearson, if you have already an account, you will not create it again. You did it work. It worked, honey. Anyways, we can ask your colleagues to help us. Okay, so what I need from you to do is to check it out more. If you are still facing problem, please drop me a message on Teams so that we can fix it as soon as possible. Okay, miss? Do we have any questions for today? Okay, so we still have only one more idea in chapter 2, which is Bernoulli's equation. See you hopefully on Thursday, miss, at 9 a.m. I think I already, let me just also share with you this one. He's right.
Now, we are still going to have a group. Still going to have a group, and I think all groups are.
Okay, either you can do it alone or ask some of them to let you join them. Okay, miss?
So I can do it. But there's a project,
What do you mean by project?
there's a project in this part.
And it's part of